All right, guys. Hope you had a great weekend. We're back with another day of series notes. Today we're talking about geometric series, so day 2 of geometric. Remembering that geometric means we're multiplying, like an exponential function, whereas arithmetic was adding, like a linear function. So um, I'm going to get through these as quick as I can. Um, the formulas that you have, so the sum of a finite geometric sequence or series, and then the sum of an infinite geometric sequence or series, those formulas will be provided. So there's no memorizing anything here, just kind of understanding when to apply the different formulas. So anything that's a sum formula today or from last week, you will have provided to you. The arithmetic and geometric, um, recursive and explicit formulas, you'll have to know those. All right, so the warm-ups, you guys can check on the key. So here's what we're talking about with a finite geometric sequence. Geometric, we again said that was multiplying. Finite means that it stops, right? There's not an infinite number. There's like a set number of terms. So if you look at number 1, the first 9 terms. For number 2, there's 11 terms, right? From 0 to 10, we do 10 minus 0 plus 1. So there's 11 terms. So there's always a set number of terms. So this means the sum of the first n terms. So it might say like S8, S12, however many terms there are. A1 the first term, R is our common ratio, N is the number of terms that you are adding up. Okay, so none of those variables change from what we've used. Here's how we can apply that. So find the sum of the first 9 terms. This formula is tricky. Most of the reason that kids make errors on this is because they don't put parentheses in the right spot. They don't actually plug it in correctly. So there's 3 things we need, right? We have A1, that's 2. There's my first term. The R value, this one's pretty obvious that we're multiplying by 3, but you can take any term, divide it by the term before it, and that'll give you your R value. Okay, so R is 3, and N is 9. So everything's kind of given here, or easy to find. So on the calculator, let's see, I need the sum of the first 9 terms. It's going to equal A1 times, and then my numerator is 1 minus 3 to the 9th over 1 minus 3. That 9 only applies to 3. Okay, so this might be the easiest way to do it. Do the numerator, 1 minus 3 to the 9th equals, okay, then we'll do the denominator. Well, that's easy, that's going to be negative 2, but sometimes it's a little trickier. And then we have this 2 in front. Well, that's really 2 over 1, right? So that 2 is part of the numerator as well. So I can do 2 times, what was it, negative 19,682 divided by negative 2. And we get 19,682. Okay. Second one. So this is a little tricky, but remember, this is the right side of the explicit formula. So an equals 16 times 1/2 to the n. I get a lot of questions on this. Well, how come it's not n minus 1? We always do n minus 1. When you're building the explicit formula, you use a1 and n minus 1. If the explicit formula is given to you, use it exactly how it is. Don't add a minus 1. Because remember, there's an infinite number of those. So I could do a2 as long as I have n minus 2. This happens to be a0, which is like 1 before the first term, which may not make a lot of sense. And then this is n minus 0. Just use it as it's provided. So the other tricky thing is to find my first term, we plug this number in. So we're no longer just blindly plugging in 1 to find our first term. The first term that I want to add is when 0 is plugged in for n. So a1 is going to equal when n equals 0. So 16 times 1/2 to the 0, because that's what it's telling me to plug in. Okay, so 1/2 to the 0 is just 1, and times 16 gets me 16. The r value is 1/2, right? That's my r value in there. And what else do I need? Number of terms. Number of terms, we take the top index number minus the bottom, and I always add 1. So my formula is going to be sum of the first 11 terms is going to be first term times 1 minus my R value, which is 1/2 to the 11th, over 1 minus 1/2. Okay, so if you're really good with your parentheses, we can just plug in as we see it. So 16 times 1 minus 1/2 to the 11th divided by 1 minus 1/2, and we get 38.984. I'm actually going to turn that into a fraction, and we get 2047 over 64. Okay, number 3. Now we want to go from when j is 1 through 6. So there's 6 terms I'm adding up. So a1 equals, when I plug in 1, so plugging in 1 gets me 1 minus 1, which is 0. For the exponent, 3/2 to the 0 power gets me 1. 1 times 4 is 4. R is 3/2. N is going to equal 6. So the sum of the first 6 terms is 4. 1 minus 3/2 to the 6th over 1 minus 3/2, 4. 83.125, 665 over 8. Okay, next page. I'm about halfway done with my time here. So the sum of an infinite, so this goes on forever. There's an infinite number of terms. Okay, so now I can't really use that n value, right? How do you raise something to the infinity power? So we have a different formula altogether. Now keep in mind, this only works if our R value is between -1 and 1. If it's beyond that on either side, let's think about what that means. Let's say I have like an R value of 2. So 2, 4, 8, 16. And this is infinite, right? So this is going to go forever. Dot, dot, dot means it's infinite. Well, let's think about what the sum of this is going to be. Eventually, what's the next term going to get to? It's just going to keep increasing without bound. So eventually this is going to be infinity, right? And then it's going to keep going. So when I take infinity and then I add other stuff to it, what does that equal? Well, that would just be infinity, right? So if you're bigger than 1 as an R value, the number is going to keep increasing forever. Eventually, the numbers themselves that you're adding will be infinity. So the entire series is going to be infinity. Same goes for if your R value is negative, then what you're going to have a different scenario. Your terms are going to keep oscillating. That means like alternating between positive, negative, positive, negative, positive, negative. And the absolute value of those terms is going to keep getting bigger and bigger, right? So you're not really going to have a sum because it's going to go from like positive infinity, negative infinity, positive infinity, negative infinity, which that's okay if you don't quite understand that, but let's just remember that it's got to be for R values only between 1 and -1. So jumping in here, we know this is an infinite series because I'm going from 1 to infinity. So this formula is a lot easier. This is probably your easiest one. So the sum is going to equal A1. Well, A1 is going to occur, I should probably find this first. A1 is going to occur when I plug in this value for my exponent, right? So if that was a 1, so 12 times 2/3, that's going to give me 8, right? So the sum you can do this also. The sum of the first infinity terms, although it's not necessary, is going to be 8 over, and then my r value is 2/3, so 1 minus 2/3, which is really 1/3. I don't even need a calculator on this one. 8 divided by 1/3, which is 8 times 3, which is 24. Okay, let's do number 2, infinite. I go from 1 to infinity. So a1 is going to be when I plug in, this is the I minus 1. When I plug in I equals 1, that's my first term. 1 minus 1 is 0, so this entire exponential term is going to 5/4 to the 0. That's going to be, ooh, wait, actually, let's hold on here. This is my r value, right? 5/4. Is that in between this range? It's not. It's not. So what do you think? If I start with 3 and then I'm multiplying by something bigger than 1 to get each next term, what's the sum of that going to be? The sum here is just going to be infinity. That's that example that I talked about. I almost missed that. I forgot that r value was bigger than 1. Okay, for number 4, now we're listing these terms out. Remember, this is a 1, 2, 3, 4. So how do I get from one term to the next? Well, the numerator, this is over 1, isn't it? The numerator is staying the same. The denominator is what's changing. How is it changing? Well, I think we can tell. Well, I'm multiplying by 4, multiplying by 4, multiplying by 4. So the r would be 1 over 4, right? And if you're not sure about that, just take any term divided by the term in front. So I could take 3/4 divided by 3, and what am I going to get? Well, that's going to give me 1/4, right? So that's my r value. First term is 3. So my sum is going to equal, again, this means it's infinite. First term divided by 1 minus 1/4. Well, that's 3/4, right? So 3 divided by 3/4. 3 times 4 over 3 gets me 4. Okay, write the following in summation notation. So summation notation, this is our sigma. I need my index numbers here, so let's use n. I want to start with the 16th term and stop with the 37th term. So start with the 16th, stop with the 37th, and then this part here should be the right side of my explicit formula. So an equals, this is a -4 times 2 to the n minus 1 using the given information. So this would just be -4 times 2 to the n minus 1. Let's see. These I think you're okay on. Maybe I'll do number 2. I'll leave the rest for you guys to do. Evaluate. So this is the sum, right? It goes from 0 to 8, so this is finite. This is geometric. So I need a1, which comes from plugging in 0 for I. So 4 to the 0 is 1 times 2 is 2. R is the base of that exponential term, which is 4. N is 8 minus 0 plus 1 gives me 9. So sum of the first 9 terms is 2 times 1 minus 4 to the 9th over 1 minus 4. I'll let you guys plug that in. I'll have the homework assignment posted. I'll PDF. I believe it's from the book, so I'll get a PDF on there. And again, I'll be available 12:30 to 3:30. And then I'm also going to post a survey that would be awesome if you guys could fill out just based on your experience so far. Thanks, guys.